everyone. Good afternoon. As he mentioned, my name is Colleen Emaus, and I'm the marketing director at 615 Technologies. For those of you that may not have heard of 615, we are a hardware manufacturing company, and we design and build head-worn displays for a number of different user segments. We've been developing wearable solutions since the early 2000s, and today I'm going to walk you through our company's journey in AR. Our first head-worn displays were designed for the military, and then we moved into developing solutions for the enterprise sector, and then I'm going to finally touch on the consumer market and what today and the near future holds. As I dive into our story, I want to quickly touch on Geoffrey Moore's technology adoption curve. This model represents how new or emerging technologies are generally adopted into the market over time. When it comes to AR smart glasses, it's interesting to point out that we are seeing AR technology follow this same adoption curve, starting with the military as the innovator or early adopter category, followed by early adopters also in the commercial space with a growing number of use cases. And today we are starting to see the adoption chasm narrow as we move from some of the enterprise use cases and early adopters and consumers with a lot of the mainstream access on mobile devices today. So starting at the beginning, if I were to do an internet search on the beginning of smart glasses, you'd find several early experiments of different scientists working in this medium. However, technology is often most successful if it aims to solve a problem and not just be a pipe dream. In 1992, the U.S. Air Force Research Lab aimed to solve a problem. How can we make our operators more productive in their workspace? From that question, they developed a properly functioning AR system that overlaid sensor information on a workspace to improve human productivity. This system was called virtual fixtures. Sure, it was crude for the time, but this was the first example that AR technology aimed to solve a real problem, not just be technology for the sake of technology. This brings me to chapter 2 of our story, designing with a purpose. Albert Einstein once said, "If I were given 1 hour to save the planet, I would spend 59 minutes defining the problem and 1 minute resolving it." For early pioneers in the AR smart glasses space, the success and later adoption of wearable displays were largely dependent on whether or not the hardware could actually solve the problem or meet the demand. First, define the problem. Second, state the reasons why it's important. Then, by understanding the requirements and trade-offs, you can align your device features and functionality into an optimal solution that addresses the problem. This purpose-built design approach is exactly how 615 built and successfully deployed one of the first head-mounted displays used on the battlefield. In 2004, the Special Operations Forces came to 615 with a problem. With a rapidly increasing number of sensors and drones being deployed in theater, military command posts now had incredible access to real-time data on the battlefield. However, getting that information to a remote operator on the ground or in flight was a major challenge. So what they did is they asked 615 to build a display system that could provide drone video feeds and critical battlefield information directly to the individual soldier in a wearable, hands-free manner. More so, they asked us to look at power, weight, display performance, and cost, all as driving factors. So what you're seeing here on the left-hand side of the screen is our solution to that problem. This system is called TAC-Eye, and it's a ruggedized head-mounted display that plugs directly into a radio that a soldier would have on its kit. The benefit that this system brought was that it gave the soldier now heads-up, hands-free capabilities without compromising situational awareness. Since 2004, Thousands of TACI displays have been deployed on the battlefield and are still the leading standard for head-mounted displays today. 615 as a company is continuing to push the technology that is being used in the military. And this system called Halo RX is currently being deployed with battlefield medics. And what it does is it's a see-through system that allows a medic that's in an austere location to be able to connect in with a doctor at a hospital in another location to provide another level of care. So following some of the work that we've done in the military that's really brought us up into the last few years, if you give someone a hammer, everything is a nail. Yes, I'm referring to the introduction of Google Glass. When Google Glass first launched in 2003, they sent out a call to the world. For $1,500 and a compelling tweet, #IfIHadGlass, you could be the first on your block to develop on Google Glass. And with this, there was this huge explosion of ideas on how people could use smart glasses in their daily lives. What did it mean? How did they interact? What did it look like? What did it mean on the whole? Inspired by these ideas, this influx of ideas, and going back to the drawing board to actually define what is the problem that we are looking to solve with a hands-free heads-up device. Specifically in the workplace, this proved to be a very valuable exercise in the AR industry on a whole. Major companies like Boeing, GE, DHL, BMW, and many more started to define what problems they were aiming to solve with smart glasses and what the business need was. How do we achieve higher productivity through assisted workflows? How do we document errors or processes so that we can transfer legacy knowledge to younger workers? How do we receive help on demand so that when I'm in the midst of a procedure, I don't have to walk away from my workspace in order to get help? How do I remotely collaborate with someone across the globe to be able to marry ideas together and come up with new solutions? The answer was a variety of smart glasses. Today, as many of you know, there are several different types of smart glasses that are all designed to do various different things, from running the spectrum from left to right of visual immersion. Are you looking to do just simple assisted reality? Are you looking to do mixed reality with a totally immersive solution? At 615, our philosophy to the enterprise smart glasses, much like our product strategy with the military, is to offer an industrial-grade accessory that adds heads-up display capability to the devices that you already own, for a ruggedized tablet that you're currently using, for a handheld phone as a field technician that you use daily, for a warehouse worker that's already equipped with a ring scanner and a wearable computer. How do you leverage that information with the existing systems deployed today to bring greater value? Regardless of which smart glasses company you choose to use in the enterprise, there are clearly commonalities across the use cases, providing all-day wearability, high reliability, long enough battery life for a shift, being physically durable. If I drop it, it won't break, and seamlessly integrating the current architecture will continue to be priorities for the industry. And this brings me to my final chapter of the story, today and the future. The advances in consumer mobile devices coupled with AR features enabled by Apple's AR Kit and Google's AR Core are bringing AR into the mainstream in a way that has never been possible before. This new technology is settling in the hands of so many consumers. And once again, we have this explosion of ideas, much like what Google did in 2013. It is no question that AR is here to stay and will continue to grow. It will expand our abilities, helping us learn new skills to live richer, fuller lives. I cannot predict when AR will truly become mainstream, but I do believe that wearable devices like smart glasses will be how people interact and experience this exciting technology for years to come. Thank you. I don't know how we're doing on time, but
I think we have some minutes left for some brief questions. Okay.
So when designing for a special forces operators, typically they have, due to the demands of their job, post-concussive syndromes, things like that, which can be exacerbated by VR technology. How do you modify your designs to account for that and improve their user experience?
Yeah, so as you may know, the military is a very slow monster that moves along, and every single one of those requirements that were built into the system, whether it was TACI, whether it was a binocular system that we've made a number of, I just shared a few of them. Those requirements are tried and true. So they come from a very long process that basically comes down from a program manager. They say, we have this problem. They go in and they talk to the operators and they say, okay, what are all the issues that potentially could wrap around this? And then before this technology is ever deployed, it's tested and tested and tested. So there are many factors that we found in the development of TACI, like light security. You know, what do we do when there's a soldier out at night, and how do we make it comfortable enough that they are not only safe but able to do their job correctly? What's the distance from the eye where they're not going to have fatigue, that it's not going to impact their situational awareness? All of those factors are things that we meticulously go through with the customer to figure out what that right optimal solution is. Yep.
What's the size of the AR market in the military or in the government branches?
So it's a really interesting question. I just came back from SOFIC, which is a special operations show, last week. And as I mentioned, so we launched TACI in 2004, and ever since then we've been modernizing that technology. With the AR advances, we're talking about see-through now, right? We're using systems like Halo RX to see what that looks like. As we've been developing that technology, so have all the other components that a soldier wears. So currently today, a soldier no longer has what we kind of call old technology. They have Android tablets. They have modern soldier systems that the compatibility to plug in these different accessory products is a lot easier. So when you talk about what is the size of this, any soldier that's in the field, also a dismounted soldier, could have a second screen to enhance their situational awareness that just plugs into existing hardware that they have. So the long and short of your answer is any dismounted soldier could benefit from this technology. It's a matter of whether the soldier kits moving forward incorporate this type of technology.
Do you have like a number?
I don't off the top of my head, no.